Okay, good morning, everyone. A couple of things about our much beloved learning management system here. So there were a couple of adds, a couple of drops. So I rearranged a few of the buddies and I boldfaced the ones that have changed. So just double check that before the lab. We're going to actually have two labs today, one in the first half and then one in the second half of the schedule that we're stuck with. So in the Dropbox, you're going to be seeing Lab 1 Part B. That's the first one for today. And then I made another one that's kind of out of the ordinary lab sequence that to help you with the homework. That's this Lab 1.5. We're going to be Lab 1 Part B in a few minutes, and then in the early afternoon we're going to be doing Lab 1.5. The other thing that I wanted to mention is, so I had a quick look at the homework too, and I just wanted to see. Yes. So here's what it looks like from my perspective. And so here's someone who submitted two files, area-tester.java and darkerdemo.java. That was good. And then over here we have someone who submitted them as RTF files. And I understand what's happening. Probably that person pasted it into a word processor and then saved the word processor files. But that's going to be bad going forward because it makes it impossible for the grader to compile it. So think of what the grader is going to do. The grader is going to suck up all of these files and put them on a directory. And then the grader is paid to work 2 hours per week on this class. The grader does not have the time to open every single file or rename it or reformat it or anything. So the grader is just going to run an automated script that compiles all of the files and looks at a report coming out of there. Later on, the grader is going to feed in some sample inputs. So to help him out, it's really important that you save these things as Java files. Now I realize what the problem is, and that is you do this work in BlueJ, and BlueJ makes a project somewhere, and then it makes these files somewhere, and how the heck are you supposed to know where they are? And so we're going to practice that a little bit later today, because you're going to have to figure out where they are. And that is something that is generally kind of interesting. It used to be that to be able to use a computer, you had to have a pretty good idea exactly where everything was put. You had to know there's a C drives and there's program files and the user directory, and people actually had a mental map of where everything was. But as computers got larger and there's more and more stuff on them, and the operating system now tries to hide a lot of those things from you, to the degree that when you go into Windows Explorer, it doesn't even show you the root, the C drive by default anymore. You have to know where to poke for it. And so people now live in this illusion that the files are all in My Documents or something. And that is true for a business user, but it's not true for a programmer. So we're going to have to figure out how to locate the files that our development environments manipulate. And the best way to do that is to just do it with a bit of practice. So I put that as one of the tasks in the lab. So the other thing that I noticed is that someone here put some questions in there and says, I wasn't really sure what to do. That's really helpful for me. So if you have any kinds of comments or questions or complaints, this is the place to put them. And I'd rather have a negative comment like, if you say, this homework was much too hard, I really hated this, or I have no idea what I'm supposed to do. If I get a whole bunch of those, that tells me to slow down. And in fact, that motivated me to make an extra lab today to practice more homework assignments. So put whatever you want me to know. Here's someone who says that he had a problem today and he met with the woman of his dreams and he couldn't possibly do the homework. These things happen. So just put those things in here, and just remember the files, Java files. Just put in genuine Java files in here. Here someone tried to zip them up. And I think the reason that person did that, and it's a rational reason, is they said, well, when I look at my BlueJ has a whole bunch of other files. In fact, let me show you that. And now you're going to see my problem in just a minute. I'm going to start up BlueJ. See if I didn't already have it. So you can see I run way too many applications at the same time. And I still haven't made myself an icon. right, so I'm now going to have this problem and say, where the heck are these files? And one way I think I can deal with this is when I do a new project, then it kind of suggests to me where some of these other projects are. So over here it has the name of a directory that for me is home temp, because that's why I put it in some temporary area, since I'm not actually taking this course for credit. And then we have here home temp area tester, I guess. So let me just open this one real quick. Sorry. And now when you look in this directory, you see there is the Java file. Then there is a whole bunch of other files. The .class file, what's the .class file? That was a question that was on the previous quiz, I think. That's the file that has the compiled instructions. We don't really care about it, but it is there. And then there is a package.bluej. I have no idea what's in that. How would I find out? So if in doubt, you want to see a right click, and then it'll say some open with, and you should have something that says open with Notepad or whatever. For me, the Notepad looks like this. And so I opened it, and there is some information that I guess makes BlueJ happy. It says, I have no clue what any of this stuff means. But it's not my code, and so that means it doesn't need to get submitted. Then there's a readme.txt. I have no idea what's in it, but we can find out. And I guess it's a where you could put in some extra information if you wanted to, which we didn't do. So the one that I'm after is this Java file. Here it is. And that's the one that you need to submit. So just make sure to find the thing and to just submit the Java file. Once you have the directory, you might need to write it out on a sheet of paper until you get fluent at this. And then you need to navigate in there and pick just the right file. And you definitely want to pick the file from the file system. You don't want to copy and paste it into something else and then submit the copied and pasted. Because oftentimes when you do that, let's say you save it in a word processor, then it'll save it as a document file. And you probably don't think about this a lot, but a document file has a completely different format, an incompatible format from a Java file, and the Java compiler can't read it. And you can verify that if you take a document. Let me see if I have one somewhere. Oh, good hell. No. Here I have it like a spreadsheet. I'm going to open it with the text editor. Yeah, I know. Oh hell. Sorry. It won't even let me open it. It's smart, it unzipped it. The point is, there's some stuff in there. Let's look at the content actually. There's stuff in there that makes no sense to Java. And so when you save it as a document, it gets turned into something that the Java compiler cannot understand. The word processor needs to store fonts and pictures and all of that, and it uses a very different format than the plain text that a Java file does. So it's important that we all get this straight. And for some of you this is very clear, for some of you this is totally new because it's the first time that you work with this kind of files. Alright, so that's what I wanted to say. On the positive note, just about everyone did turn this stuff in. And so it's really important to me that you turn in something. So if you have no idea what to do, you must at least be able to turn in something that has the name of the program that kind of compiles and does nothing. Turn it in and then add a comment that says I'm lost. That way I know. All right, moving on. And the other thing I wanted to point out in Desire to Learn is, and this may or may not be useful, in the calendar I put in the videos that from the lectures, and so let me find it. So I like to put everything in the calendar, that way it's all in one spot. Like here, our lecture videos, and I just give you the YouTube links. And they are the single most boring thing that I have ever watched in my life. But if you remember that I said something significant somewhere in the lecture, you can just go in there, you can pan forward and try to find the thing and see if you can find that particular word of wisdom. And so you may find that helpful. I'm not recommending that you go and listen to the entire thing again, right? Unless you really have nothing better to do. But maybe over Labor Day, right? So the only reason I'm putting them there is, in case you wanted to refresh your mind on a particular point. And that way you know it's there. And so I'm trying very hard to always keep them there. The audio quality isn't the greatest, but it should be good enough to look things up. All right, so in the first few minutes, I want to go through this section on algorithms and why we care. Then we're going to have a short lab, and then we regroup and get into chapter 2 and the longer lab. All right, so we don't care about this. Let's look at this example here. So over here we have an example of what's called an algorithm. So an algorithm is a procedure, a decision procedure that follows a particular set of rules that we develop. So this particular algorithm here is for deciding which car to buy based on the total cost. And so the idea is that some cars are cheaper, some cars are more expensive when you pick them up at the dealer, but it doesn't matter whether they're fuel efficient. You might be willing to spend more money for a more fuel efficient car, and conversely, if a car is a gas guzzler, you might pay less money at the outset because you know that over time you're going to have to pay more. And so how do you find out what's like the total cost over some period of time that's important for you? So over here, we're going to say we're going to keep that car for 10 years, say. That's the decision we're going to make. And so we're going to compute the total cost. And so here there's the algorithm says what one should do. One should figure out what are one's annual miles driven. For me, I might assume I drive 10,000 miles a year. Then I would take the fuel efficiency. And so the algorithm says I should divide them over one another. And that gives me the annual fuel consumed. So for example, if I drive 10,000 miles, fuel efficiency is 20 miles per gallon. Then that would take me, this is math, what did I say? 10,000 over 20, what's that? That's 1,000 over 2, that's 500. So that would take me 500 gallons to drive my 10,000 miles. Then I would come up with some price per gallon. Of course, I have to come up with some estimate because I can't foresee the future. I don't know what gas is going to be costing, but let's say it's going to cost me $4 per gallon. So then the cost for that would be $2,000. So yeah, I'm going to assume that the price per gallon is $4. So then the operating cost would be 10 times that. So that would be $20,000. Now that's actually kind of interesting. 10,000 miles is not very much. I mean, that's just enough for commuting. So you're going to be paying $20,000 just in gas over the life of the car. So if the car cost you $30,000, so let's say the purchase price was $30,000, then the total cost would actually be $50,000. And now you can do the same calculation for the other car, and then you can figure out which one is cheaper. Well, this is not exactly rocket science, right? This is just a basic decision process that you might go through if you actually buy a car on a rational basis instead of looking at which one has the nicer wheel trim. So, and what's the point? The point is that each of these steps here is a step that is completely regular. As long as you have the inputs, you can follow these steps one step at a time, and you're going to be getting some answer. The answer is either choose car 1 or choose car 2 in this case. But so the calculation is completely deterministic. It takes some inputs, it crunches through them one step at a time, and it arrives at an answer. And so such a thing is called an algorithm, named after some Arabic mathematician from hundreds of years ago. And it's kind of the lifeblood of computer science. When we want to compute anything at all, we have to have such an algorithm. You can't write a program without having some underlying algorithm. And so the algorithm has to be unambiguous. Unambiguous, for example, means that when we look at the price per gallon, we're really going to have to say that has to be a user-provided input. The program can't guess what that price per gallon was. It can't look in the future. So if the algorithm says, look in the future and find what the price per gallon is over the next 10 years, that wouldn't be an algorithm because it would not be possible to do that. But if the algorithm says, ask the user what they think the price per gallon is going to be in the next 10 years, that's okay. The user might be wrong, but it's an input to the algorithm. So an algorithm is the sequence of steps. So this was a somewhat complicated algorithm to show that it's worthwhile doing this kind of stuff. And for the next couple of weeks, the programs that you write are going to be so much simpler that it seems hardly worth doing it. But as we go further down, the programs are going to ramp up in complexity, and it is well worth taking pencil and paper and writing up the steps that are necessary to do a task. So, and you do that in what's called pseudocode. So pseudocode is an informal description of an algorithm. And in chapter 1, where we know next to no Java, all the pseudocode is just kind of in plain English. Later on, what people often do is they mix a little bit of English and a little bit of Java in their pseudocode. And the pseudocode omits some of the more tedious steps. So over here, we say for each car, and then we do something. Whereas, as you'll learn later, when you program this in Java, you have to actually have two variables, car 1 cost, car 2 cost. And that's just tedious. So you omit kind of the tedium, but you capture the basic idea. So we use indentation in this algorithm here to say that for each car, everything that's indented here should be carried out for each car. We use equations, just kind of mathematical equations, except in mathematics, one always uses symbols, x, y, t, t1, c1, or something like that. And here you can just use words, total cost, purchase price. You can even put spaces in the words, even though those are not legal Java identifiers. Later, when we translate them to Java, we just get rid of the spaces. So you just write it in a kind of semi-formal way so that if you were to give it to a reasonably intelligent assistant and say, hey, do this, the reasonably intelligent assistant would be able to do this in an unambiguous way, not up to his or her interpretation, but they could just simply follow the rules. That's what an algorithm is. When do you want to write one down? Whenever you have something where there's more computation going on than you can instantly envision. And we're going to be seeing an example of that just a little bit later today, where it's really helpful to write down the steps on a sheet of paper. So actually, one of the most powerful tools that a computer scientist can have is a sheet of paper, and it's important that you always have one available. So on a sheet of paper, you want to sometimes write these sequences of steps. On the other hand, I had someone come to my office hour who had the solution to one of the homework problems, which was like 20 lines of code written down on a sheet of paper, and that is probably not a good use of paper because it's tedious to then retype it, and if you, of course, the computer doesn't take the paper. So paper is great for thinking before coding. And there's always this question: how much thinking should you do, and how much coding should you do? And so some people don't like to think at all. They instantly go to the computer and they type. And that's fine, but then what some people do is they type, they get stuck, and then they make random changes, and they try again. They make another random change, and that takes too long. You don't have enough time to explore your solution space like that. So if you find yourself making random changes, totally random changes, just because you can't think of what to do, that's not going to be a successful strategy. Then you should walk away. And my wife keeps telling me, whenever I yell at the computer, she says, Kai, you need to walk around the block. And she's always right. Because this happens, right? You just want to get it done, and it doesn't work, and you get upset, and you get frustrated, and you try something else, and that doesn't work either. And that really is the time to start thinking. And every time I do that, it's bad, but I do. And So you want to make sure that you then sit back and think. And one way of thinking is to write down on a piece of paper with a pencil, not a pen, but with a pencil, the steps that you think you need to do. And it often clarifies your mind greatly. So it's a very good tool. And you just have to know what is the balance between planning and thinking versus coding. On the other hand, there's some people who want to have everything planned out up to the most minute detail before they fire up the computer. And that doesn't work either, because what happens, if it works for you, great, do it. But if it doesn't work, if you get stuck, if you say, gosh, I'm going to obsess about the fact that I don't yet know how this part works, you should try to make a smaller task and try that on the computer, because you learn so much from the mistakes that you make. One really does. You make a mistake, the computer does something that's different from what you thought, and by watching what it does, you often say, oh, that's what he meant. And so you really want to find a good balance between experimenting and not just randomly thrashing around. So experimenting is good, thinking is good, and it's your job to mix those two. And it's not an easy thing to do. So I'll talk more about that in the next module. The point I want to get into is that pseudocode is a very simple concept. It simply means write down the steps that are necessary. Use math when you can. Use a verbal description when there is nothing mathematical, like for each car. Choose car one. I mean, there's no math involved there. You just use the words. And you write down this sequence of steps on a sheet of paper to aid yourself in understanding what it is that you need to do. All right. So I did want to go quickly into this idea of this experimenting. Someone asked a question about the homework with with that frame window thingo. Let me find this. Sorry, this is the wrong one. All right, the translate demo. All right, so let's copy and paste this. I'm in the lucky position that I can copy and paste. If I do this to you again, where I give you a long piece like this, where you would have to retype it, could someone please put a thing on Desire to Learn that says, can you give this to us so we don't have to retype it? Obviously, I have it in electronic form, and you're not learning anything by retyping it, I think. The thing that you do, and that several of you did, is you introduce mistakes, just silly typing mistakes, and then it doesn't compile, and then you just fret over stuff that's not worth fretting over. So next time, just ask and say, I want it in electronic form. I think that's a very reasonable thing to want to do. Where's good old Blue Jay? Okay. Oh, and here, in fact, already have it. All right, so here I pasted it in, and I'll take out again. And so this is the stuff right as it came out of the box. So let me compile it, and let me run it. Okay, it said click OK to continue. And if you look very carefully, you see a very pathetic little window here. Do you see that? This actually is a window. I can make it bigger. Well, if I try really hard. Yeah, it is actually a window, but it came out originally very small because the default size is 0 by 0 pixels. Not a very useful size for a window. So what were we supposed to here? It says construct a rectangle. Okay, how do you know how to construct a rectangle? Let's see if the book offers any. So actually, could you turn this in as a draft? Yeah, it compiled, right? It ran. So it's better than nothing. At least it got you to start thinking about this problem. But it would be nice to go a little bit further here. So let's try to construct a rectangle. And where is my... Oh, I can't even find my own thing anymore. variables, assignment operator, objects, classes, and methods. Gosh, one really has to skip ahead here. Why did no one complain? Okay, so here it says to construct a rectangle. Because you found the solution on the internet, yes. All right, so I'm going to construct a rectangle. And now it says, and set the frame bounds. Okay, I'm going to just show you how to do this so that I get my point across. So I have this frame and I want to call a method on it. And it's very nice in BlueJ. When you hit Control Space, and apparently wait a long time, then it shows you all of the methods that a frame understands. Actually, a frame understands a lot of methods. Look at this. I haven't seen most of these. Oh, this is crazy. This is many more than I remember. The one that we want is set bounds, and it's over here. So we pick it. All right, let's try this. And now I'm going to compile it. Okay, cannot find. Oh, what? Okay, why didn't it find it? What did it do wrong? Okay, what should I have done?
You didn't define a rectangle.
That's right. But I made a rectangle.
You called it box.
Over here I called this thing box, and then here I typed in rect because I wasn't paying attention. So let me fix it. Okay, so I compile it. Let me run it. Ooh. Okay. Now, when I first saw this, I said, "Gosh, now what happened?" And then I had the insight to move this thing away, and here is my window. And if you look very carefully, notice that it's 20 pixels wide and 30 pixels high. I can't count pixels for the best of them. So this was probably not a very good thing here. So how about I make these much bigger? And how about I move it a little bit over? And now let's try this again. Okay, so now you saw the window appear, and then the box appeared, and now it no longer completely obscures it, so that was a better idea. Now, I would have never been able to do this in a million years if I hadn't tried something out. Because when you write it down on a piece of paper, are you really thinking about the fact that the pixels are actually kind of tiny and that it might be obscured by the dialog box? That's something where you have to have some kind of experience. Also, what if I had not seen the thing? First it was like the tiny thing, the dialog box was there, clicked OK, and everything went away. It went so fast that I might not have noticed it. But at this point, I would have had enough material to put a question up on Desire to Learn that says, when I ran this program just the way it was in the book, it didn't do anything at all. It just showed this dialog box. So what gives? And that's a perfectly good question, because at that point, someone else, maybe one of you who figured this out, can spring into action and say, yeah, but if you actually look carefully, or I could then look at it and say, well, yeah, that might be would be worth trying. But then you have something that you can talk about. You can say, I've run this experiment. Now, someone said, well, what if I put the code for that out on Desire to Learn? That's cheating, because then everyone else can take my code, and then they don't have to do all of the work. And so every professor is different about this particular aspect. My philosophy is that if you put any old code on Desire to Learn that is not 100% correct, that has at least one mistake in there, go for it. Because what's the cheating? If someone else actually goes through all of the desire to learn things that pop up, and there'll be soon lots of them, and takes the trouble to read through this code, makes their own independent judgment of what's good and what's bad about it, they are thinking, they're working, they're learning. I see nothing wrong with that. Now, so don't worry about putting something on it. You shouldn't put a perfect solution on there and say, hey guys, look at my great solution. I mean, that's obviously not very helpful. But if it's in the context of an honest question, something that doesn't work perfectly, please go and put it on Desire to Learn on the discussion board with that crappy user interface. Put it on there and let other people poke at it. That way other people can copy and paste it. They can try it out, maybe because they think there's some good ideas in there. And they can say, well, these are some good ideas, but you need to do X here. And so it's perfectly okay to give someone a hint and say, try this. It's fine. It's what people do all the time. And if collaboratively you get to some solution, don't post the final solution. Other people should at least be retracing the steps. But it's okay to do that. I'd rather have you talk to each other and exchange these hints on the public forum where you can see what's going on than to 5 minutes before something is due say, hey, can you give me the solution on a USB stick? I mean, there's no learning going on in there at all. So go ahead and post anything that you want as long as there's a question attached to it. And if there's a partial solution, that's fine. Now, conversely, if you feel that you've taken something that's 90% of the solution and it's not your work, and you say, but you end up taking it, it would be a good idea to say, I took this from this Desire to Learn posting. As long as you attribute it, and as long as you honestly say what was going on, I will never take any points off. As long as you say, this is what I did. I took it from there and then I modified it. Then, if it gets out of hand, it's my problem to put a lid on some of the Desire to Learn postings. But it's okay to take out anything there. What you can't do, of course, is you can't really say, well, I took the entire thing from my friend. And you can't say, well, I paid someone on the internet or something. But as long as it was there in a reasonable context, then you can paste it. And if it's more than just a few lines, you should attribute it. You should say, this is where I've taken it from. And that's normal. People do that all the time. All right. So the value that I want to get here is to try to figure out what it is that you want to achieve in these homeworks. Read through the assignment. See what the heck they're supposed to mean. And it's not always clear. And then the next thing, you should try to run some experiment. Grab some code that is a fraction of the assignment and whip it into shape so that it runs, just like what I've done here. I've copied and pasted the code, I ran it, it did something strange, I made some change to it, and I learned something from that change. And so that dual process, planning and experimenting, both of those are essential parts to getting the homework done. All right. And so the third component is to ask questions. I've purposefully given you a set of hard homeworks so that you would see that these are not trivial things. You can't do them on your own. You have to ask questions. Well, some of you can do them on your own, but some of you read. Ask those questions. And ask them on Desire to Learn. You get points for asking questions. You get points for answering questions. You use it whenever you're stuck. And even if you say, I'm totally stuck, give me a pointer on how to begin. That's an actionable item. I can give you a pointer on how to begin. That way I know that you need such a thing. And just ask that question. All right. The other thing is, if a couple of people left me comments that say they ran out of time. And I know how I feel. Because these things always take longer than you think. Right? And because there's always some stupid thing that should be working and it doesn't work. And then how are you going to solve that so quickly? My response to that is try to do it a day early. There's no law that says you must deliver it exactly at 11:59 or as close to as possible, as humanly possible to that point. Right? You could just do the entire thing a day early. You could just shift time by 24 hours. And you should give that a try. It really does work. All right. I will say that many times during class. Now let's go on to the lab. So for this first lab here, where's my Desire to Learn? For this first lab, we're just going to finish up the Alice assignment. And so I will be walking around, and I want to see the toaster fly, whatever it was, the beach chair, whatever it was. I want to see that everyone got to that point so that I know that your machines have now been set up correctly. So go and do that lab. You switch the scribe and the driver. Whoever was the scribe last time is the driver for this module for just half of today. Whoever was the driver last time is now the scribe, and the other way around. And then you submit the thing right into Desire to Learn like you did last time. So.
So should we stay in the group?
Okay, you should stay in the groups you started in unless you see your name in bold here, which means that I made a change.
But we're both still in class, even though you made a change later on me, and for both of us.
When I made a change, I made it for a reason, which at this point eludes me, but then. Yeah. Okay, then how about you put the two together here?
Yeah.
It looks like it's getting emptier.
Yeah.
So
Yeah, we'll go over there.
I think it's worth taking it.
We'll go here? Yeah.